This is the F-35 Lightning II, the most advanced fighter jet in the USA's arsenal. 1 minute, it's invisible. The next, it's launching off a carrier deck at Mach 2, ready to dominate the airspace. But this isn't just some souped-up airplane with cool gadgets. The F-35 is a flying fortress, packed with more technology than some space missions, engineered to outmaneuver and outgun anything that crosses its path. Behind each one of these jets lies a mysterious world of innovation and secrecy. We're talking about materials so rare they're worth their weight in gold, radar systems that make it virtually invisible, and a building process that's so classified most people on the assembly line only know part of the story. So, if you're wondering how this comes to life, stick around, because we're diving into the classified factories and labs where the F-35 Lightning II, the F-22 Raptor, and others are meticulously crafted. The design blueprint. At companies like Lockheed Martin, Northrop Grumman, and Boeing, teams of aeronautical engineers start with the design process, laying the foundation for what will become a next-generation war machine. This design phase can take years. The F-35 Lightning II, for example, is a jet that took decades to perfect, requiring countless design revisions to optimize its performance and stealth. And it's not just about the jet's shape. Engineers must also consider internal systems. This includes fuel efficiency, heat management to evade infrared detection, and placement of weapons within the jet's structure for stealth. And finally, the design must be approved by military experts who oversee the project. They scrutinize every element, ensuring it meets the high standards of the U.S. Air Force and Department of Defense. Only then, when the blueprint has been rigorously evaluated and refined, can the jet move into the next stage. Once the design is in place, it's time to choose the materials that will bring it to life. Consider the forces acting on a fighter jet mid-flight. Traveling at over 1,500 miles per hour, these jets experience extreme temperatures as friction heats up the surface. A traditional metal would buckle under such stress, so the jet's skin must be made from a combination of heat-resistant alloys and composites. Titanium is a common choice for fighter jet frames as it's incredibly strong yet light enough to keep the jet agile. But the real magic lies in composite materials, carbon fiber and radar-absorbent coatings designed specifically for stealth. Stealth is, in fact, one of the most crucial aspects of the F-35 and F-22. More on that coming your way, but before we continue, remember to hit that subscribe button if you're new to this channel, because, let's face it, who wouldn't want to be part of the elite squad learning about jets that could outfly your neighbor's car? The engine assembly. The engine is the powerhouse of any fighter jet. It turns raw fuel into unstoppable thrust that propels the aircraft through the skies at blistering speeds. Building an engine for a fighter jet is unlike building any other kind of engine. These engines must be incredibly powerful, compact, and reliable under conditions that would make most machinery break down. For the F-35 and F-22, engineers turned to Pratt & Whitney's F-135 and F-119 engines, two masterpieces that set the standard for power and efficiency in fighter jets. Assembly of these engines is done with almost surgical precision. Each component, from the fan blades to the afterburner, must be perfectly aligned, as even a fraction of a millimeter can affect performance. The F-135 engine used in the F-35 is particularly noteworthy because it generates up to 43,000 pounds of thrust, making it one of the most powerful jet engines ever built. This power allows the F-35 to perform a vertical takeoff, a feat that few fighter jets in the world can achieve. Beyond sheer power, these engines are designed for stealth. Unlike traditional engines that leave a heat trail, the engines of the F-35 and F-22 are engineered to reduce infrared signatures. This makes it harder for enemy missiles to track the jets by heat. Advanced cooling systems and heat dispersal techniques ensure that the jet remains undetectable even at full throttle. Wings and aerodynamics. Designing these wings requires a deep understanding of aerodynamics, as they must be optimized to slice through air with minimal resistance while supporting advanced combat maneuvers. For the F-35 and F-22, this balance is critical. The wings need to be sturdy enough to handle high G-forces in a dogfight, yet sleek enough to maintain supersonic speeds without excessive drag. To achieve this, engineers begin with computer simulations. Using complex models, they analyze airflow around the wings at various angles and speeds. This simulation process reveals the ideal shape for maximum lift and minimum drag, allowing the wings to contribute to the jet's agility. For the F-35, a focus was placed on creating a wing design that would work for both vertical and conventional takeoffs, a feat that required groundbreaking innovations. The wing materials themselves are lightweight yet robust, often made from a combination of titanium, aluminum, and composite materials. The wings are reinforced to handle the intense stresses of rapid maneuvers. This structural integrity is vital, as even the smallest flaw could compromise the jet's performance or endanger the pilot's life. Avionics and advanced technology. The cockpit of a modern fighter jet is its nerve center, packed with cutting-edge technology that enables pilots to operate with unparalleled awareness and precision. For the F-35 and F-22, avionics and integrated systems are what makes these jets truly formidable, giving them an edge over older aircraft and adversaries. Avionics refers to all the electronic systems within the aircraft, from radar and navigation to communication and flight control. Advanced avionics allow these fighter jets to detect threats and lock onto targets long before the enemy is even aware they're in the vicinity. One of the standout technologies in the F-35 is the Distributed Aperture System, which uses a series of cameras and sensors to provide the pilot with a 360-degree view of the surroundings. This God's eye view is displayed on the helmet visor, allowing the pilot to see through the walls of the aircraft, enhancing situational awareness like never before. Another crucial aspect of the avionics system is radar. The F-22 uses an advanced radar system that can track multiple targets simultaneously, and the radar is also designed to avoid detection by enemy sensors, adding another layer of stealth. This active electronically scanned array radar is agile and precise, allowing the jet to engage targets from significant distances while remaining nearly invisible. The F-35's radar also incorporates electronic warfare capabilities, enabling the jet to jam enemy radars and confuse missile guidance systems. But avionics goes beyond just sensors and radar. It's about connectivity. In modern warfare, information is power, and the ability to share that information in real time is a game changer. The F-35, for instance, is designed as a networked jet, capable of communicating seamlessly with other aircraft, ground stations, and naval vessels. This means it can act as a central hub in the battlefield, gathering, processing, and distributing information to allied forces. Stealth technology. One of the defining features of America's top fighter jets is their ability to operate unseen. For the F-35 and F-22, stealth is an integral part of their effectiveness, enabling them to penetrate hostile airspace, conduct missions, and return undetected. Creating a stealth-capable fighter jet involves several layers of engineering. First is the design itself. The unique angular shapes of these jets aren't merely aesthetic. They serve a purpose by reflecting radar waves away from enemy receivers. Unlike conventional aircraft, which might reflect radar signals back to their source, the surfaces of the F-35 and F-22 are crafted to scatter these signals in multiple directions, making it much harder for radar to detect them. The next layer of stealth comes from materials. Both the F-35 and F-22 are covered in radar-absorbent materials, which are specially formulated to reduce radar reflection. This coating is meticulously applied to the jet's surface, and even a tiny scratch or misapplication can compromise its effectiveness. Because of this, maintenance of the jet's stealth coating is a high priority, with technicians trained to handle these materials under strictly controlled conditions. In addition to radar stealth, these jets also employ measures to reduce their infrared signatures. Fighter jets generate intense heat due to their powerful engines, making them easy targets for heat-seeking missiles. The F-35 and F-22 incorporate advanced cooling techniques and specially designed exhaust nozzles to disperse heat, making it harder for infrared sensors to lock onto them. Stealth extends to electronic stealth as well. The avionics and communication systems are designed to minimize emissions, reducing the chance of detection by enemy signals intelligence. Each of these stealth features is tested rigorously. This involves exposing the aircraft to simulated radar and infrared detectors, ensuring that it can evade detection in real-world combat scenarios. The combination of shape, material, and heat management turns the F-35 and F-22 into silent predators, capable of entering and exiting hostile territories without being seen. Equipping the jet for battle. A fighter jet's purpose goes beyond flying. It's built to be a lethal force. The F-35 and F-22, for instance, are equipped with advanced missiles, bombs, and guns designed for precision and versatility. A key feature is their internal weapon storage. Unlike older jets with external hardpoints that compromise stealth, the F-35 and F-22 house weapons inside to avoid radar detection. They carry both air-to-air and air-to-ground missiles, each suited for specific combat roles. The F-22 typically carries AIM-120 AMRAAMs for long-range targeting and AIM-9 Sidewinders for close-range dogfights, while the multi-role F-35 can deploy precision-guided bombs like the GBU-12 Paveway 2 for ground strikes. Loading these weapons requires meticulous mounting on internal racks, with rigorous testing to ensure smooth deployment without compromising stealth or aerodynamics. The F-35 also accommodates both conventional and nuclear weapons, depending on mission needs. Weapon integration with avionics allows the pilot to engage multiple targets accurately. This sophisticated targeting system ensures quick, precise reactions to threats, making the F-35 and F-22 formidable airborne arsenals. Final assembly. After years of research, testing, and fabrication, the fighter jet reaches its final stage, assembly. Here, specialized engineers in high-security facilities work meticulously to ensure every component fits flawlessly. Assembly begins with the core frame, followed by precise engine installation to optimize efficiency and reduce vibrations. Wings and tail fins are then attached with exacting care to maintain aerodynamic balance. Once the structure is complete, avionics and weapon systems are installed, connecting miles of wiring to link controls, sensors, and weapon bays. This complex stage is thoroughly tested to prevent any electrical faults. And finally, technicians apply a sensitive stealth coating in controlled environments to maintain its effectiveness. The jet undergoes a final inspection before its maiden flight, testing its capabilities in real-world conditions. So, that's how these fighter jets are made. Next time you see one slicing through the air, remember how it all started. Thank you for watching, and don't forget to like, subscribe, and join us next time for more amazing insights.